Hi. Okay, so in this video, what we're going to do is talk about adding fractions, and we're going to talk about something that's called least common denominator. It's also called least common multiple. So those are two things that we're going to be tackling in this video today. Okay, so let's of course go through the steps of what we do when we add fractions. Then we'll talk about that least common denominator thing. So for adding fractions, our first step is to check and see if the denominators are the same. And I'm going to abbreviate that to denom, like I have been. Okay, so if they are, then we keep the same denominator. I was going to change my mind, and then I changed my mind about changing my mind. So we're going to keep the denominator, and we're going to add our numerators. I don't want you to think that means number. So we're going to add the numerators. If they're not, then we have to find something called the least common denominator . This is also abbreviated LCD. So we find the least common denominator. We change our numerators based on the LCD. And then we add the numerators. And of course, even though I kind of put steps within steps, our last step is always going to be to reduce if necessary, or not if necessary, if we can. So I'm just going to come over and zoom this in so that you could see those no steps a little bit better, because my marker started to dry out a little bit, unfortunately. So what I want to do is talk about this concept of least common denominator. I'm going to zoom this out again. You have a worksheet that you're going to be doing that's called least common multiple. A least common multiple and a least common denominator are really pretty much the same thing. So least common multiple, on this worksheet, it's two numbers . I'm just going to kind of do a comparison here with least common denominator. So with least common denominator, it's still two numbers . And I'm using blue now, so I'm just going to angle the camera just a little bit differently so that you can see this a little better. Because I'm trying to get darker markers, and I don't think it's working. Okay, so least common multiple is two numbers. Least common denominator, two numbers. So the least common denominators are already in a fraction. Least common multiples They're just numbers that are hanging out there. They're not in a fraction. They're not in a problem. They're literally just two numbers smacked next to each other. So really the only difference between a least common multiple and a least common denominator is that the denominator is already in a fraction. That's it. So for both least common multiple and least common denominator, what our goal is going to be is to find one number that both numbers, whether it's a multiple or a denominator, doesn't matter. We want to find a number that both of the numbers can go into. So that means the number has to be bigger than those two numbers. So for example, if we used the numbers 2 and 14, right now, because they are not part of fractions, they're going to fall under the least common multiple category. Literally, if I drew these as fractions, they would end up as least common denominators. That's the only difference. So, your worksheet that you have for this talks about least common multiples, and this is what they look like. And it's just two numbers, and then you have to find the multiple, or the least common multiple. But in the addition worksheet, you're going to have to find least common denominator. So that's why I wanted to make sure I addressed both of these. Okay, so what we need to do is find one number that 2 can evenly divide into and 14 can evenly divide into. So that means whatever number we find has to be at least 14 or higher. So one trick that's really, really helpful to do this is to, especially if you're more of a visual learner, I'm going to zoom this out just a little bit so I have a little bit more board space that you could see. So especially if you're a visual learner, this is helpful. So we're going to take both of our multiples, and I'm just going to write them on top of each other. Okay? And above it, I'm going to write the multiplication tables, what I'm going to multiply these numbers by. And you're going to see I'm going to use this chart in that worksheet also. Okay, so 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And I'm just going to keep going for time's sake. And I went up to 14, or up to 2 times 7. So 14 times 1 is 14. 28. 42, and I'm actually going to stop because now I already have two numbers that match, so I don't have to keep going. And I'm just going to zoom in so you can see how I have those two numbers circled. If I went, sometimes there are two multiples and you might end up with several matches, but again, remember that the L stands for least. So you're looking for the smallest match. So the least common multiple between 2 and 14 would be 14, because 14 divides into 14 once, and 2 can go into 14 7 times. That's this concept of least common multiple, least common denominator. Okay, so let's zoom this out again, and let's do some problems with adding fractions. So remember, these are our steps. We're going to check that sorry, my face is like in the corner of this. We're going to check that their denominators are the same, and then we're going to go from there. That's really our essential first step, is are these denominators the same or not? Usually, students love when the denominators are the same, because then they don't have to go through this mess. So one worksheet of adding fractions, you'll notice all the denominators are the same, so you might like that worksheet a whole lot better than the other one when they're not. But I have to make you practice. So let's work on some of these. My board is getting a little dirty because I've done so many lectures today. I'm so sorry. Okay. Yeah, I know, I'm throwing a curveball at you right off the beginning. So 2/3 plus 4/3. It doesn't necessarily matter what the numbers are. So it doesn't matter that this second fraction is improper. It just matters, are the bottom numbers the same? So in this case, the bottom numbers are the same. So we're going to slide that denominator over. We're not going to add them together at all. We're going to keep it exactly how it is. And now we just add the top. So 2 plus 4 is 6. So now we still have an improper fraction that we have to deal with because the top number is bigger than the bottom number. So if you remember from our previous video, the way that we fix this is we divide the bottom number into the top to see how many times it'll evenly go in. Luckily, we know 3 times 2 is 6, so our answer is going to be 2. Okay, let's do 1/8 plus 3/8. The dirtier this board is getting, the lighter my markers are getting. I'm sorry. Okay, so our denominators are the same. So all we do is slide it over, keep it exactly the same. And now we add our tops. So 3 plus 1 is 4. But we're not finished yet because this can still get smaller. So what number can evenly go into 4 and the same exact number evenly go into 8? That's what we're looking for. So we can definitely reduce this by 2. I know that the number 2 can divide into 4 and it can divide into 8. So we could use 2. So 4 divided by 2 is 2. 8 divided by 2 is 4. But that can still get smaller, can't it? Say yes. So I can still divide this by 2 again, and I end up with 1/2. Some of you might not have taken this middle step, and some of you may have just reduced this by 4 and jumped right to the 1/2, and in which case, totally fine. Some people need to reduce in more steps until it's a fraction that they're a little bit easier to handle. So whichever way you get there is fine. It just matters that you get there. Okay, so let's work on ones where the bottoms are not the same, because they're the ones that are kind of the hardest to wrap your head around because of that least common denominator thing. Two sixths plus 1/3. So immediately when we look at this, we know that our bottom numbers are not the same. 6 and 3 are not the same numbers, just in case you didn't know. So we need to figure out what is the smallest number both of these can divide into. So let's use our little trick. So I'm going to put our multiples here, and then what we're going to divide or multiply them by. So I'm going to multiply by 1, 2, 3, 4, 5, 6, and these are my multiples. So I'm just going to fill this in, 3 times 1, 3 times 2, 3 times 3, that's what I'm doing. I hope you're doing it with me, unless you've already figured out the answer. Okay, So once I've done this, and there's really no rule about how many numbers you have to go up to, you kind of just ballpark. So now I'm going to circle my matches. So I went up to the number 6, and I ended up with 3 matches. I think you can see those circles. So 6, 12, and 18 are all matches. So we want the smallest number. So that means 6 is going to be our least common denominator here, because these are already in fraction form. So now, because we're going to change the bottom, the top is going to have to change. So when the denominators change in an addition problem, the numerators have to change too. And this is usually the part that gets a little tricky. Some students really work well when the problem is actually written vertically with one number on top of the other so they can see what they have to do. So I'm just going to rewrite the problem that way. I'm going to show you both ways. I'm going to show you vertically, and then I'll show you horizontally how to do this. So what we do when we write this vertically is we write our new denominator next to it, and now we have to figure out our new numerators, our new tops. So to get our new top number, we have to do to the top whatever we did to the bottom to get the new denominator. So 6 times what gives me 6? 6 times 1 gives me 6. So if I multiply by 1 on the bottom, I have to multiply by 1 on the top. So 2 times 1 is 2. 3 times what gives me 6? 3 times 2 gives me 6. So if I have to multiply by 2 on the bottom, then that means I have to multiply by 2 on the top, and 1 times 2 is 2. When I add these together, it's the same thing. Now my denominators are the same. That's the point behind trying to find the least common denominator, is to make your bottoms the same. So now 2 plus 2 is 4. We are not done. We have to reduce that. So I'm going to reduce by 2, and my answer is going to be 2/3. And I just drew my line slanted because I'm down at the bottom of the blackboard, or the whiteboard. Now this can be done the same exact way, but done horizontally or across, depending on what you like. So it's the same, all I'm doing is the same exact thing, but I'm doing it across instead of up and down. So it would be 6 divided by 6 is 1. 1 times 2 is 2. 3 goes into 6 twice, or I have to multiply 3 by 2 to get 6. So that means I have to multiply 1 by 2 to get 6. And I get the same top answer and the same final answer. Finding the numerators is the hardest part when you're adding fractions with different denominators. That's why a lot of people like it when it's written this way, because then you can actually mark up what you're multiplying by to be able to change the top numbers. When you do it this way, I mean, you could technically, of course, still mark what you're multiplying by, but it's a little bit more difficult to visualize. So usually for people, as soon as I write it this way, it seems to click a little bit better. Okay, let's try another one. And this time, I'm going to ask you, as soon as I write this, of course the denominators are going to be different, so you're going to have to find the least common multiple. So once I write these fractions, you're going to put me on pause, and you're going to figure out the least common denominator yourself, and then we'll move along with the problem, okay? I have to figure out what the problem is first. Okay, so 2/6 plus 3/4. Make sure you put me on pause so that you can figure out the denominators and you're looking for the lowest one. And then when you come back and hit play again, I'm going to work through this problem. Okay, so while you were gone, all I did was rewrite the same problem, but I did it vertically in case you like looking at it that way. So your least common denominator is 12. If you chose 24, it's not technically the least common denominator. The other issue is that because it's a bigger number and you could have picked something smaller, you're just going to end up reducing in the end. So on the worksheet for least common multiple, you would technically get the question wrong, but if you were just adding these fractions, by the end the reducing would kind of catch up with you and help you, so you'd probably still get the answer right. Okay, so I can still illustrate it. I'm going to work it out this way. So I had to multiply 4 by what to get 12? I hope you said 3, because that's the right answer. So that means I have to multiply the top by 3 as well to get 9. I have to multiply 6 by 2 to get 12, which means I have to multiply 2 by 2 to get 4. So now my denominators are the same. So I bring the denominator down, and then I add the top. So 9 plus 4 is 13. And what kind of fraction do I end up with? Where the top is bigger. I really, really, really hope you're saying an improper fraction, because you're right. So we have to turn this into a mixed fraction. So to get our whole number, how many times can 12 fit inside 13 evenly? Once. We drag our denominator over, and our numerator is whatever is left over. So 1 times 12 is 12, minus 13 is 1. So our answer is 1 and 1/12. If that went too fast, make sure you watch the lecture video on moving from improper to mixed and mixed to improper. So let's work it out this way. 6 into 12, 6 divided into 12 is 2. 2 times 2 is 4. 4 into 12, or 4 times 3 equals 12, and 3 times 3 equals 9. So I get the same answer. Again, usually to be able to see the steps and actually see what you're doing, most people like doing it this way, you know, until they start getting the hang of it. But it's totally your call. All right, we're going to just do one more because I know this video is getting long. And we're going to do the same thing where you're going to tell me what the least common denominator is. So I'm going to write the problem. You're going to put me on pause. One-eighth and 2/6. Apparently I have something for 8s and 6s today. Okay, so our least common denominator is 24 in this case. Unfortunately, we don't have one that is smaller, or do we? What did you figure out? Sometimes you look at two numbers and you think 24 and then you're like, maybe I should check my math. So let's check our math, just in case. Could we have something smaller? So when we use our technique, nope, nothing smaller. 24 is as small as it gets. So let's work it out this way this time, since I've been doing the other ones that way. Okay, so I have to multiply 8 by what to get 24? It's over there if you need the help. So 8 times 3 is 24. 3 times 1 is 3. So I'm going to do that same fraction over here. So 8 times 3, 1 times 3. I know you can't see this, but I'm leaning over tables. I think I mentioned it in the other video, so I'm like reaching because I'm so short. Okay, 6 times what is 24? So 6 times 4 gives me 24, which means I also multiply 2 by 4 to get 8. So now that my denominators are the same, I slide my denominator over or down, depending on which way you're doing this. And then I add my tops together. So 3 plus 8 is 11. And even though 24 could be reduced, the number 11 can't, because the only things that will go into 11 are 1 and 11 cannot go into 24. So that is our answer. So when you get to the worksheet where they have the same denominators, like I said, you'll probably like that one better, because you'll cruise through that one a little quicker. But then there's also the other one where the other worksheet has fractions with different denominators. So you're going to have to find least common denominators. I would suggest there is a separate worksheet on least common multiples where it just gives you the two numbers and you kind of go through this step to find what the least common multiple would be. So it would be a good idea to do that worksheet before you do the worksheet where you're adding the fractions with different denominators. So I will see you in the next video. Bye.